Hello children, welcome to Math Park. Today we are going to solve exercise 9B. This is going to be solved in two parts. In this part, we are going to solve first 10 questions. So children, if you like the video, please do not forget to share with your friends. And if you are new to the channel, please subscribe. So we're going to start with the first question now. Of AB and AC of triangle ABC. So you are given a triangle ABC over here. So this is your triangle ABC. And on this triangle, two equilateral triangles are drawn. So ABD is one of the equilateral triangle and ACE is another equilateral triangle. And you have to prove that angle CAD, that is this angle CAD is equal to angle BAE. So these two angles you have to prove. So what you can observe over here, so first thing is, since these are equilateral triangles, this angle is going to be 60 and this angle is going to be 60, correct? So therefore, first part, let us begin. We have angle DAB, angle DAB is equal to angle CAE because they are angles of equilateral triangles. These are the angles of equilateral triangles. Now, this angle is common. What part we are going to prove, that is angle CAD, this angle is common to both. So let me take this part as angle 1, or we can take it as angle BAC. Okay. So angle BAC, if I add BAC to DAB, I am going to get CAD. If I add BAC to CAE, I am going to get BAE. So this equation, just we add angle BAC or angle 1 to both sides. So we get angle DAB plus angle 1 is equal to angle CAE plus angle 1. Now this angle 1 plus this is nothing but angle CAD is equal to angle BAE. Got it? So we have proved the first part of this. Clear? Now in the next part, next we have to prove CD is equal to BE. Now CD and BE proving equal, we need to understand which triangles we have to prove congruent. So to prove these two triangles congruent, to prove CD and BE equal, which triangle we have to prove congruent? That is the thing we have to properly observe. So let us start with in triangle CAD and B congruent to triangle EAB. Okay. Now in triangle CAD and EAB, you have already proved angle CAD is equal to angle EAB. This you have proved above. Okay. The next thing when you have to look at this triangle. You have, if you say AD, this AD is equal to AB. This AD is equal to AB because ABD is an equilateral triangle. AD is equal to AB because ADB is an equilateral triangle. ADB is equilateral. Correct? Now the next, when you look at, see here, AC. So CA, this CA is equal to EA. Correct? So you have CA is equal to EA. Why? Because you have ACE is an equilateral triangle. Is equilateral triangle. Correct? So therefore you get triangle CAD is congruent to triangle EAB by which test? By SAS. And therefore you get CD is equal to BE CPCT. CD is equal to BE or EB because here the corresponding way is EB by CPCT, and we are done with this question. In this question, ABCD is a square and APB is an equilateral triangle. This is P over here. And in each case, you have to prove triangle APD, that is this triangle APD is congruent to triangle BPC. So we'll start with the figure 1 first. We begin with the figure 1 first. Okay. And you have to find the angles of DPC. We have to find the angles of this triangle DPC. Okay. Let's start with this part. So we start with the first part of the triangle. So we have in triangle, we start with the figure 1. So we start in triangle APD. and triangle BPC, what all things we have? So do we have AP is equal to BP? Yes, because APD is equilateral triangle. So we have AP is equal to BP. Then we also have AD is equal to BC. AD is equal to BC because this is a square. So these two sides are equal again. Okay, AD is equal to BC. And what about this angle included? Okay, this complete angle is 90 degree. So this, if this is 90 and this is 60, this is going to be 30 degree. Okay, so this is how you get this angle DAP is equal to 30 degree. So you get angle DAP is equal to 90 minus 60, which is equal to 30 degree. And same way you have angle CBP. Angle CBP is also equal to 90 minus 60, that is 30 degree. So these two angles you got equal. Okay, so this is also 30 degree because this is complete. So therefore you get triangle APD is congruent to triangle BPC by which test? By SAS. By SAS. This side, this angle, and then this side. Okay. And now we have to find the angles of triangle DPC. Now for finding the angles of triangle DPC, we have this angle as 60 degree. Okay. So, and this 30 degrees. So and these two sides are equal because AD is also equal to AP. This is an equilateral triangle. AB is equal to AP and AD is also equal to AP. So therefore you get, since you get AD is equal to AP, you get these two angles equal. If these two angles are equal, by angle sum property we try find the triangles. If this is 30, then this is going to be 180 minus 30, that is 150. Okay, then half of 150, these two angles are going to be 75 and 75. These two angles are going to be 75 and 75. Similarly, you are going to get these angles also to be 75 and 75. So this is how you get in in triangle, let us write it down. In triangle APD, you get angle ADP is equal to angle ADP is equal to angle APD is equal to 75 degree. I hope you understood how we did that. And similarly, you are getting these two angles also 75 degree. Okay. And also you get angle BPC is equal to angle BCP is also equal to 75 degree. Right. So this is how, and now we have to get a complete angle. Now this is going to be a complete angle, right? So therefore you get angle DPC. This is your P. So you get angle DPC. Angle DPC is equal to 360 minus, we add all of these angles, that is 75 plus 75 plus 60, which is equal to 210. So which is 360 minus 210. So which is 150 degrees. So you got this angle as 150 degree. Okay. Now we have to find the another angles. Now this is complete angle is 90 degree. This angle D is 90 degree. Angle C is 90 degree. So you get angle PDC. Angle PDC is equal to 90 minus 75, which is equal to 15 degree. You also get angle PCD is equal to 90 minus 75, again that is 15 degree. So this is how you get the angles as 150 degree and 15 degree and 15 degree. When you add, you are getting this all angles at 180 degree. Got it? For figure 2, let us start proving triangle APD and BPD congruent. So we have AP in this triangle APD and BPC. We have again AP is equal to BP because this is an equilateral triangle. So we get AP is equal to BP. Okay. The second thing we have again AD is equal to BC because again this is a square. So you get AD is equal to BC with the same reasons as we did in the previous part. So you get AD is equal to BC. Now the third thing is about this angle. So this is 90 and this is 60. This is square and this is an equilateral triangle. Again, this is 90 and this is 60. right? So this is how you get angle. You get angle DAP. Angle DAP is equal to 90 plus 60, which is 150 degree. Also, this is also equal to angle CBP. Angle CBP is also equal to 90 plus 60, which is equal to 150 degree. Okay, so this is how you got these two angles equal. So you have two sides and included angle. So therefore you get triangle APD. This triangle APD is congruent to triangle BPC by SAS. Triangle BPC by SAS. Got it? So how? And now we have to find the angles of triangle DPC. To find the angles of triangle DPC, now you have this 150 degree because AP is equal to AD. AP is also equal to AD. So you have AP is equal to AD. So this becomes 50 degree. These two angles are going to be 15 and 15. Okay. So because this becomes an isosceles triangle, these two sides are equal. So it becomes an isosceles triangle. So AP is equal to AD. Therefore, you get angle ADP is equal to angle APD is equal to 15 degree. Did you understand how did we get this 15 degree? Okay. And similarly, also you will have a same thing. You have even BP is equal to BC. So therefore, you get angle BPC is equal to angle BCP. Angle BCP is also equal to 15 degree. These also are going to be 15 degree by using the isosceles triangle property. Now, if this is 15 and this complete was 60 degrees, so therefore you get angle DPC. Angle DPC is equal to 60 minus this 60 minus 15 plus 15. These two are 15 and 15. So this is how you get 60 minus 30, that is equal to 30 degree. Okay. So you got this angle as 30 degree. This is 30 degree you got one angle. Now you have to find these angles. Now this is a 90 degree and this is also 90. To get angle PDC. Angle PDC is equal to 90 minus 15, which is equal to 75 degree. And also you get angle PCD. PCD is also equal to 90 minus 15, which is equal to 75 degree. So this is how the angles of this triangle DPC you get 30, 75 and 75. Got it? In the figure given below, triangle ABC is right angled at B and APBQ and ACRS are squares. You have to prove that triangle ACQ and ASB are congruent. So we start with the third question. In triangle ACQ and ASB, ACQ and ASB, ACQ and ASB, what all things we are able to get equal? Let us see. So we have AQ is equal to AB. Why is this AQ and AB equal? So we have AQ is equal to AB because AB PQ is a square. ABPQ is a square. Correct? The next thing you have, if I look for this triangle, okay, you get AC is equal to AS. So also you get AC is equal to AS. Again, because ACRS is a square. This is a square. Okay. The next we will have the included angle. So what included angle? See, look, this angle is 90 degree and this angle is 90 degree. So if I add angle 1, I'm getting this included angle equal. Okay. So then you get angle QAC is equal to 90 degree plus angle BAC. BAC is common to both. And also, if I talk of this angle, so for this triangle, angle QAC, if I have taken, this is BAS. So angle BAS is also equal to 90 plus angle BAC. And therefore you get angle QAC is equal to angle BAS, correct? And therefore you get triangle ACQ is congruent to triangle ASB by SAS. Okay, and therefore you get CQ. Therefore you get CQ is equal to B. If it is CQ is equal to SB by CPCT, and SB is nothing but BS. Got it? In triangle ABC, so let us take triangle ABC. You have AD is a median. BD is in triangle ABC, BD is a median. So BD is a median, and BD is produced to E. BD is produced to E such that BD is equal to DE. These two parts are equal, and you have to prove AE is parallel to BC. This is what you have to prove. Okay. So for that, we will be taking these two triangles congruent. These two triangles will have to prove congruent. So let us start with the proof of this question. So we have in triangle ADE and triangle, if I take ADE, I should take CDB. In triangle ADE and CDB, first thing is we have angle ADE is equal to angle CDB. This angle ADE is equal to angle CDB because they are vertically opposite angles. The next, because this is a given, again you have this DE. DE is equal to DB. This is given to you. This is given to you. The next we have this part, AD and CD are equal. So AD is equal to CD because BD is median. Median divides the opposite sides into two equal parts. So therefore, you get triangle ADE is congruent to triangle CDB by which test? Look at this side, angle side by SAS. And if the triangles are congruent, we have the corresponding parts. Now we have to focus on, we have to prove AE is parallel to BC. For proving AE parallel BC, we know that two lines are parallel if alternate angles are equal, correct? Now, which two angles we can have equal? If these two triangles are equal, you can see this E of this is equal to B of this. So, I can have either these angles equal by CPCT, okay? Or I can take this angle equal by CPCT. So, any one angle if I take, this becomes a alternate angles. For this A and C equal, AC is a transversal. For E and B equal, BE is a transversal. So we get angle DAE, or you can write here this is angle 1 is equal to angle 2. So you get angle 1 is equal to angle 2 by CPCT. Okay. And since these are alternate angles, but these are alternate angles. And if alternate angles are equal, you get the lines parallel. So therefore, you get AE is parallel to BC. Got it? Given figure QX and RX are the bisectors. So you can have this angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Okay. And you have to prove, and XS, this is perpendicular. XS is perpendicular to QR and XT is perpendicular to PQ. You have to prove that triangle XTQ is congruent to triangle XSQ. Okay. So let's start with the first part. So in triangle XTQ and triangle XSQ, so you have, first of all, this is 90 degrees. So we will have angle XTQ is equal to angle XSQ is equal to 90 degree, correct? Because these are the perpendiculars, XT and XS are perpendiculars. Then we have angle 1 is equal to angle 2 because QX bisects angle Q. Next, we have xq is equal to xq common. So we have xq is equal to xq common. Okay. So therefore, you get the triangles congruent by AAS. So therefore, you get triangle XTQ is congruent to triangle XSQ by AAS. Got it? So now we have proved these two triangles congruent. Now next is we have to prove PX. So let us join PX. PX bisects angle P. That means you have to prove these two angles equal. So for that, let us have a construction. Let us draw XV perpendicular to, let us draw XV perpendicular to PR. Okay. Now XV is perpendicular to PR. Let us prove these two triangles congruent. Okay. So if XT is equal to XS, first of all, if XT is equal to, if XTQ, triangle XTQ is congruent to XSQ, so we get XT is equal to XS by CPCT. Okay. Now we have, similarly, we will be able to prove these two triangles congruent. So we have in triangle, again, we start with XSR and triangle XVR. We have angle XSR is equal to angle XVR is equal to 90 degree. Okay. Again, we have angle 3 is equal to angle 4 because RX is bisecting this angle. RX bisects angle R. Angle R, correct? And we have, which is XR is equal to XR common. This XR and XR is common. So we have XR is equal to XR is common. Okay. And therefore you get triangle XSR is congruent to triangle XVR by which? Again by AAS, by same way. And therefore you get XS is equal to XV. This is second part, let us say CPCT. Okay. The first part of this equation, let us take this as first part. You have XT is equal to XS and XS is equal to XV. From these two things, you get XT is equal to XV. This is from 1 and 2. Okay. Observe this 1 and 2. You have XS is equal to XT. Okay. And XS is also equal to XV. Therefore, you get XT is equal to XV. Now we will take triangles. In triangle, let us take these two triangles now because we have to prove this bisects. So we have in triangle XTP and triangle XVP and triangle XVP. You have angle XTP is equal to angle XVP is equal to 90 degree. This is given. You have XT is equal to XV. You have proved just above. You have proved it. Okay. And next you have XP is equal to XP common. XP is equal to XP is common. Okay. So what do you get over here? One side, one right angle, and then the hypotenuse. So therefore you get triangle XTP is congruent to triangle XVP by RHS. You get this congruent by RHS. Okay. And if these triangles are congruent, let us take this angle 3 is equal to angle 4. So therefore, you get angle 3 is equal to angle 4 by CPCT. And then hence you can say, and therefore, I'll write it up there. So therefore, you can say PX bisects angle P. Done? Number 6, in a parallelogram ABCD, A and C are obtuse angles. Then XY, you are taken here. The points X and Y are taken on the diagonal. So this is your point X. This is your point X. X and then another point Y is taken on the diagonal such that angle XAD, this is 90 degree and angle YCB is 90 degree. Okay. And you have to prove that XA is equal to YC. So proving XA is equal to YC, which triangles we need to prove congruent, that we have to focus on. So which are those triangles? So let us start with in triangle. Let us start with the proof. Given to prove, you have to write, children. Okay. So in triangle XAD and triangle YCB, Let us understand what all things are given to us. So what is clearly known to you? AD is equal to CB, correct? Why is AD is equal to CB? Why AD is equal to CB? Because these are opposite sides of parallelogram. Opposite sides of parallelogram are always equal. Okay. So this one thing we got. The next we have angle XAD is equal to angle YCB is equal to 90 degree. This is given. This is given to you. Correct. Now we have to find one more thing. So we have AD is equal to BC we have taken, and we also have one angle, this 90 degree. Now one more thing we want. So what is that one more thing which we can have in this? So we can have this angle is equal to this angle. Why? Because they are alternate angles. These two lines are parallel, so these become alternate angles. So we get, let us take this as angle 1 and let us take this as angle 2. So you get angle 1 is equal to angle 2 because they are alternate angles. These are alternate angles, and therefore you get triangle XAD is congruent to triangle YCB by which congruence? Observe carefully. By angle, side angle. This side is in between. Look at this. This is the side in between this angle. So by ASA, the triangles are congruent by ASA, and therefore you get XA is equal to YC by CPCT, that is, if the triangles are congruent, the corresponding parts are also equal. Okay. Question number 7, we have a parallelogram. Okay, ABCD is a parallelogram. The sides AB, the side AB is produced to E and side AD is produced to F, such that you have AB is equal to BE. These two parts are equal. Okay, and you have AD is equal to DF. Okay, you have to prove triangle BEC is congruent to triangle DCF. So BEC, this angle BEC is congruent to triangle DCF. So let us start. So we have in triangle BEC and triangle DCF. Okay, so what all things we have? We have AB is equal to, DC because they are the opposite sides of a parallelogram. Okay, AB is equal to DC because they are opposite sides of a parallelogram. Correct? But AB is also equal to BE. Okay, this is, they are opposite sides of parallelogram. Opposite sides of parallelogram, and this is given to you. Okay, AB is equal to B is given to you. So from these two, do you think from these two, from this is say 1 and 2, from 1 and 2 you get DC, you get BE is equal to DC. B is equal to DC from these two equations, correct? So one part we got equal. Now the second thing, this is one thing we got equal. What about the next part? Again, we have AD. Again, we have AD is equal to BC because they are opposite sides of parallelogram. Again, they are opposite sides of parallelogram. Okay. And these two are AD is equal to BC. But we also have AD is also equal to DF. Okay, we have AD is equal to DF. So from these two, what we understand? We get BC is equal to DF. So we get BC is equal to DF. Okay, now we got two things. We got this part and we got this part. We need one more thing for proving the triangles congruent. So what is that one more thing we have? Can we have this angle 1 is equal to angle 2? They are corresponding angles. Angle 1 is equal to angle 2. These are the corresponding angles. Because DC is parallel to AB and AF is the transversal. Same way, you have angle 2 is equal to angle 3. Again, they are corresponding angles. Because AF is parallel to BC and B is the transversal. From these two things, you understand that angle 1 is equal to angle 3. So this is the third part that you got, the star ones. Okay. So you have B is equal to DC, you have BC is equal to DF, and you have angle 1 is equal to angle 3. So therefore, you get the triangles. Therefore, you get triangle BEC is congruent to triangle DCF by SAS. Got it? How SAS? This side, this angle, and then this side. Okay. Again, this side, this angle, and this side. By SAS, the triangles are congruent. Hence, proved. In this question, in the following figure, question number 8, in the following figure, the sides AB and BC and the median AD of triangle ABC are equal to sides PQ and QR. So what is given to us? So let us write, you are given AB is equal to PQ. Then you are given BC is equal to QR. And you are also given median AD. You are given median AD is equal to median PS. Okay. And you have to prove triangle ABC is congruent to triangle PQR. This is the thing you have to prove. Okay. So for that ABC and PQR, we have only two things. We have AB is equal to PQ. You have BC is equal to QR. But something more we needed. For that, we will be proving these two triangles congruent first. So we first start with in triangle. We start with the proof. So we begin with proving the triangles congruent. So which triangles? In triangle ABD and triangle PQS, you have AB is equal to PQ is given. Then also you have AD is equal to PS. These two things you can write the common reason given. And the next thing is you have BC is equal to QR. So if BC is equal to QR, you can have half of BC is equal to half of QR, because how can we divide by multiply both by half? Because AD and PS are medians. So what does the medians do? The medians divide the opposite sides into two equal halves, right? So that is why we could multiply this equation by half. So half BC is nothing but BD and half QR is nothing but QS. So you got these three things, 1, 2 and 3. So you got the three sides, okay? So these two are equal, okay? Also you got BD is equal to QS. So therefore you get triangle ABD is congruent to triangle PQS by SSS. And therefore you get angle B is equal to angle Q. Therefore you get angle B is equal to angle Q by CPCT. Now we start with in triangle ABC and triangle PQR. You have AB is equal to PQ is given. Then you also have BC is equal to QR. These two things are given. Okay. And you have proved angle B is equal to angle Q. Okay. And therefore you get triangle ABC is congruent to triangle PQR by SAS. Got it? In the following diagram, AP and BQ. So you are given, so what is given to you? You are given AP is equal to BQ and they are parallel. So AP is also parallel to BQ. Okay. These are parallel and these are equal also. You have to prove that triangle AOP is congruent to triangle BOQ. And AP and BQ bisect each other. If AP and BQ bisect each other, do you understand? That means AP and BQ are making equal parts of each other. Okay. So what we have to prove? AO is equal to BO and PO is equal to OQ. Then we can say that AP and BQ bisect each other. So let us start first part of this. So we have in triangle AOP and triangle BOQ. So what do we have straight away? So first thing we have AP is equal to BQ is given to you. This is given. Okay. Then you have angle AOP is equal to angle BOQ. Why? Because they are vertically opposite angles. Okay. Now we got two things. We need one more. What do you say about these two angles? These two angles? Because we know that AP is parallel to BQ and AB is a transversal. So therefore, you get angle A is equal to angle B. They are alternate angles. Alternate angles. Why? Because AP is parallel to BQ. So therefore, they are alternate angles. So therefore, you get triangle AOP is congruent to triangle BOQ by what? By AAS. Angle. This angle, and side. So by AAS. Okay. And therefore you get AO is equal to BO. You get AO is equal to BO by CPCT. And also you get PO is equal to OQ. So you get, or you can say OP is equal to OQ, both by CPCT. And since you can see that the parts are equal, so therefore you can say that AB and PQ bisect each other. AB and PQ bisect each other. They are making two equal parts of each other. Got it? And today's video, the last question we are doing now. So in this, OA is equal to OC and AB is equal to BC. You have to prove that. So given directly, it is given over here. So please write down that. So this is the given thing. OA is equal to OC and AB is equal to BC. You have to prove angle AOB is 90 degree and triangle AOD is congruent to triangle COD and AD is equal to CD. So we start with the first part. So first part, since we have to prove this is 90 degree, first let us prove these two triangles congruent. So we say in triangle AOB and triangle COB, what all things you have? You have AB is equal to, you have AB is equal to CB is given. Also you have AO is equal to CO, AO is equal to CO. These two things are given to you. Okay, what is the next thing you can have? The next you have OB is equal to OB is common. So you have OB is equal to OB is the common side. Is the common side. So therefore you get triangle AOB is congruent to triangle COB by SSS. Three sides are congruent. And therefore you get angle AOB is equal to angle COB by CPCT. These two angles got equal. These two angles you got equal. Okay. Now these two angles, they also form a linear pair. So therefore you get angle AOB, you get but angle AOB plus angle COB is equal to 180 degrees because they stand on a line. They form a linear pair. Okay. And now in place of this COB, can I write AOB from here? So you get angle AOB plus angle AOB is equal to 180 degree. So you get twice angle AOB is equal to 180 degree. Or you get angle AOB is equal to 180 upon 2, which is equal to 90 degree. Okay. So we proved the first part. You understand, for proving the first part, how did we start with these triangles? Now we have to prove the triangle. Now if this is 90 degree, okay, so therefore you are also going to get this angles also 90 degree. And therefore you will also get angle AOD also and angle COD will also be equal to 90 degree because these two lines intersect. Even if one angle is going to be right angle, these all four are going to be right angles, right? So now we start with the second part. So we say in triangle AOD and triangle COD. So you have, first thing is you have AO is equal to, you have AO is equal to CO. This is given to you. Then you have angle AOD is equal to angle COD is equal to 90 degree. Just now we have said that. And the next you have OD is equal to OD common. So OD is equal to OD is common side. And therefore you get this is common and these two sides are equal. So therefore you get triangle AOD is congruent to triangle COD by SAS. And the triangles are congruent. You get AD is equal to CD by CPCT. And this is the third part. Got it? Understood, all of you? Okay, next video, we'll have the next 10 questions of this exercise. So if you like the video, children, please do not forget to share with your friends. And if you are new to the channel, please subscribe. Thank you for watching. Have a good day.